Okay, today we're going to do chapter 5.2, the binomial expansion of a plus b to the power of n. And the two formulae that you need to know is this one, a plus b to the power of n, this whole long thing there. Don't worry, later I'll show you how to apply this formula. And this formula, right, is actually given in the examination for your formula sheet. Similarly, the other formula that you need to know for this part is this one as well. This is also given in your formula sheet. So without much further ado, I'll just show you how to apply the formula. Just take down the two formula, know that they are given in the examination, and I will start, okay, with the few questions. So let us begin. Okay, so today the questions I'm going to do will be 1a, 2b, and 3c. So let's start with exercise 5.2, question 1a. Okay, for 1a, they say expand each of the following binomials 2 minus x to the power of 3. Okay, so if you want to apply the formula, alright, you just try to cross-reference the formula. First one is a to the power of n. So the first one is a to the power of n, alright, plus n choose 1. Okay, so see, so first is 2 to the power of 3, then it is 3 choose 1, okay, then we put again the a, then now, just now here was 3, okay, now we will have 3 minus 1, so just now initially was 2 to the power of 3, now will be 2 to the power of 3 minus 1, then we bring in the negative x to the power of 1, so here will be n minus r. Then the next term will be 3 choose 2. You notice how this is increasing? Then it will be 2 to the power of 3 minus 2, negative x to the power of, here's n minus r, and here will be r. Okay, and the last term will be 3 choose 3. Alright, then we have 2 to the power of 3 minus 3, negative x to the power of 3, like this. Then here is where we have to simplify everything. 2 to the power of 3 is 8. 3 to the power of 1 is 3, choose 1 is 3, sorry. And here will be 2 square times negative x plus 3 choose 2. Okay, if you have a problem, just press calculator here. Okay, we have 3 choose 2, which is 3. 2 to the power of 3 minus 2 is 1, to the power of 1. And negative x square will give you x square. Negative times negative will give you positive x square. Plus 3 choose 3. 3 choose 3 will give me 1. Can? So this part here will give me 1. 2 to the power of 3 minus 3. 3 minus 3 is 0. 2 to the power of 0 is also 1. And here, negative x, negative cube. Okay, negative times negative is positive x squared. Positive x squared times negative x give me negative x cube, like this. Then you start to simplify everything. We'll get 2 times 2 is 4. 4 times 3 is 12. 12 times negative x will give me negative 12x. Here will be 3 times 2 is plus 6x squared. And here 1 times 1 is 1 times negative x cubed, so we get negative x cubed. And we have fully expanded 2 minus x to the power of 3, and that is question 1a. Let me adjust the camera upwards so that we can see more of the screen. And we are done with 1a. Now, I'll carry on with question 2b. 2b, the question is this. Okay, 2b, they say that find the first 4 terms in ascending powers of x. So I get half plus x squared to the power of 12. Okay, just try to follow as I do this. So the first term will be half to the power of 12. Notice that this half, right, first one is the power of 12, next one will be power of 11. So, okay, next one will be 12 choose 1. This 12 choose 1 comes from the Pascal's triangle we learned earlier. Then I get half the power of 12 minus 1, which is 11. Okay, and here the second term b is x squared to the power of 1. So notice, right, half will be 12, 11, then later will be half the power of 10, half the power of 9, while x squared will be x squared to the power of 1, x squared to the power of 2, x squared to the power of 3, and so on and so forth. So as the powers of the half, the a term, are decreasing, the power of the b term, in this case x squared, will be slowly increasing. So the next term we have will be 12 choose 2, half the power of 12 minus 2, which is 10. Okay, and we have x squared. Notice the x squared will square. So this is the power of 10, this is power of 2 is 12. Here's power 11, power of 1, total is 12. So I have so far 1 term, 2 term, 3 term. I need a 4th term. Okay, not enough space down here, so I write next one. The next term will be 12 choose. We have 12 choose 1, 12 choose 2. Next one will be 12 choose 3. Okay, half the power of, now this power is decreasing, 12 minus 3. And next one we have x squared to the power of, you guessed it, 3. Then plus dot 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 dot. We just leave it to say that it goes on. Okay, then we simplify. Half to the power of 12. Okay, half to the power of 12, if you just key into your calculator, you get 1 over 4096. Okay, plus 12 choose 1 is 12, half to the power of 11. Okay, half to the power of 11 times x squared. This x squared to the power of 1 is still x squared. Then we have 12 choose 2. Okay, let me key that. 12 choose 2 is 66. So this term gives me 66, half to the power of 10. Then here will be x squared square will be x to the power of 4. And the last term, the 4th term, 12 choose 3. So I key there, 12 choose 3 is 220 times half to the power of 9x. You open the bracket here, it will be 2 times 3. So it's x to the power of 6 plus dot dot dot. The plus dot dot means that there are still some more terms at the back, but we are just not bothering about it. So I simplify 1 over 4096. Just key half times 12 times half to the power 11 to your calculator. What you should get is 3 over 512. Okay, let me show you this part here. I will key 12, okay, times half, half to the power of 11. So I get is 3 over 512. So here I'll get 3 over 512 x squared. Okay, similarly for this part I key for you to see 66 times half to the power of 10. So I key 66 times, okay, no need there, half to the power of 10. What I get is 33 over 512 x to the power of 4. And last but not least, this one, if I key in everything correctly, which I'll just shortcut here, I should get 55 over 128 x to the power of 6 plus dot 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 dot. And I've completed 2b so far. And these are the basics, right, of using the expansion for a plus b to the power of n. Okay, take some time to actually work it out by yourself. Don't just blindly copy the notes. Try to see how the formula actually interacts. You can notice the pattern. Once you actually notice the pattern, as in how the a term slowly, right, starts at 12, it decreases to 11, it decreases to 10, it decreases to 9, and the b term, x squared, first x squared to the power of 1, then x squared to the power of 2, x squared to the power of 3, it slowly increases. Similarly for this one, you notice it starts with 2 to the power of 3, then the next term is 2 to the power of 2, the next term is 2 to the power of 1, last term is 2 to the power of 0. Negative x starts with nothing, but at the next term it will be negative x to the power of 1, negative x to the power of 2, negative x to the power of 3. So there's that pattern down there. Once you have realized this pattern, everything becomes quite easy for the expansion of a plus b to the power of n.